Rahim. I am Hussnain Ali from Bagh School, grade 12 and 13 chemistry teacher A levels. Today, students, our topic of discussion is first electron affinity and its trends in the periodic table. So, here you can see the trend of electron affinity within the periodic table. That electron affinity increases from left to right in the periodic period, while it decreases down the group. So I have given the ionization energy and atomic radius trends also so as to correlate with the electron affinity trend, as we would be explaining these factors. Here, for the sake of the trend of first electron affinity down the group, the electron affinity decreases down the group. The reason behind it are, the first reason is, as you go down a group, more energy levels are added to the atom. Electron gets farther away from the nucleus, therefore the nuclear pole decreases. Electron affinity is the love for electrons, as affin means to love electrons. So as we go down the group, as the atomic size is increasing, the incoming electron is to be added to the ultimate shell of the atom. Ultimate shell is moving farther away down the group from the nucleus, so the nuclear pull decreases, so the electron affinity decreases. Secondly, the shielding effect increases and decreases the attraction for the incoming electron. So students, what happens, what we mean by the shielding effect is that the internal electrons, except the ultimate electrons, shield the nucleus pull on the outermost shell electrons. As we know, our electron that is to be added in the case of first electron affinity, it is to be added to the ultimate shell. So the pull of the nucleus on the incoming electron decreases due to the increase in the shielding effect as we go down the group. You can see the AS notes about the shielding effect and correlate this point with the electron affinity. Thirdly, the nuclear charge does increase down a group. We know that the atomic number is increasing, proton number is increasing, which tends to make a confusion that it might be happening that the electron affinity should increase, but it is not the case. It is the reverse case, as the increased nuclear shielding compensates for this increase in proton number down the group. So the shielding effect that is discussed before, it compensates the proton number increasal effect, and these two effects nearly cancel out each other, and the only effect that is responsible for the electron affinity decrease is the atomic size increasal as we go down the group. So these were the trends down the group for electron affinity. For the sake of trend of first electron affinity across the period from left to right, the electron affinity increases from left to right in a periodic table. The reasons are, across the period from left to right, no new energy levels are added to the atom. So what happens is that the atomic size is not increasing. The incoming electron is added to the outermost shell, where the nuclear pull is holding that electron. Secondly, the shielding effect stays the same. The number of shielding electrons remain same, means there is no effect of the shielding electrons from left to right in the periodic table. Atomic size decreases as the proton number increases and nuclear pull increases on the incoming electron. What happens is that across the period, no energy levels are increasing. Shielding effect is remaining same. What is happening is, basically the proton number increasal is making the nucleus more powerful, and it attracts the incoming electron to a more extent, thus releasing an energy to a more extent so as to stabilize the incoming electrons effect within the atom. That is why the electron affinity increases or becomes more exothermic across the period from left to right. Students, thank you for your kind listening. Allah Hafiz.